Hello. Good afternoon, everyone. So, can I have a So, hello everyone. I think everyone is tired. So, we'll keep it short. I'm going to steam through the vehicle dynamics aspect, which is required for Maha vehicle. How you will tune your vehicle to get the best performance out of it. How you can basically apply the theory of Newton's laws and everything, the basics aspects, and how to get use those equations to tune your vehicle for different events like maneuverability or suspension or endurance or acceleration, braking, everything. So let's get started. So what is vehicle dynamics? Anyone can define? Anyone? Come on. Study of vehicle motion, right? Anyone else? So, vehicle dynamics is basically the study of forces acting on the vehicle. So, the application of classical mechanics on like on evaluating how the vehicle characteristics is going to be. So, what are different kind of vehicle characteristics? So, those are the ride comfort, how the feeling of the vehicle is while driving. So, that is ride. Then comes the handling, uh, how the vehicle is performing in order when the driver is giving the input. Uh, is it oversteer, understeer, or neutral steer? So those vehicle characteristics comes under the handling part. Then comes the kinematics and compliance, which basically deals with how the suspension, I mean the works during the vertical motion, the lateral motion, or the compliance part when the forces are applied to the suspension. So, vehicle dynamics is characterized into three aspects. First is longitudinal dynamics. So, application of longitudinal dynamics will come into picture for the acceleration test, the braking test, the sledge pull, or the hill climb. So, the equations that we are going to derive will help you to define the gear ratios required to get the best possible acceleration time or the best possible torque required or the traction required for the hill climb. So we will apply the longitudinal dynamics in getting the performance for this test. Then comes the lateral dynamics. So lateral dynamics will help us to define how the maneuverability of the vehicle will be. It will be help us to tune the vehicle in such a way that the you can survive or you can get the best possible lap time in maneuverability. Then comes the vertical dynamics. So this comes for the endurance test. So yeah. So we define vehicle dynamics in the beginning that it is the study of forces. So now how does this forces are generated? So there are different type of forces for longitudinal dynamics. There comes the longitudinal force. So how it is generated? Let's look into that. So every like if the wheel is traveling, I mean from one the vehicle is traveling from one place to another place. It is through a wheel, right? So wheel is first rotating in it itself, and it is also translating. So the combination of rotation plus the translation of the wheel gives the combined effect of moving the vehicle in particular direction. So this is the combined effect is called as rolling. So this rolling is basically it generates the forces, the longitudinal forces. So how? Let's look at how. So Tires are basically the elastomers, the viscoelastic material. So whenever a viscoelastic material is compressed, it it comes back to its original position when the force is released. But the path followed in the returning motion is not the same. Let's say it has followed the curve of like this in compression. It will come back with a different path with some extended material left behind. So this causes the slip in the tires. The slip is something which is directly proportional to the longitudinal force which is generated. So longitudinal force is generated when the vehicle is in acceleration or braking. So in so you can see in this graph. Okay. So this graph, you can see it is for initial slip, it is directly proportional, then it stabilizes after certain forward slip. So there is a difference, as I said, the viscoelastic property of the tire generates the slip, and this slip is directly proportional to the longitudinal force. So this is how the force is generated in the x direction of the wheel. So so let's look at how the load transfer happens during braking and acceleration. So let's consider our Baha vehicle, which has a CG, which is shown. This is a approximate CG location. This may not be real for you, for you guys. So let's consider our CG is there. So our vehicle is accelerating. So the inertial force will act in opposite direction. It's basic Newton's law. This is the weight of the vehicle, which is stabilized, which acts at the CG. So this is B is the location of CG from the front axle, and C is the location from of the CG from the rear axle. And F real, this is the traction force which is there, which helps your vehicle to propel in the forward direction. This force is generated from the torque developed by your drivetrain system. So, and this is the reaction force in the front and the rear axle. So let's apply the Newton's law. As I said, we will just use the Newton's law and derive certain equations which will help your vehicle to get tuned in a better way. So we have applied the Newton's law in x direction and as well as in the z direction. The summation of force is equal to like the summation of all the forces at particular point is 0. So we have just applied those equations in x and z direction, and also we have find out the moment in the about the y direction. So we'll get the reaction forces in the front axle and the rear axle. So now, what is particular in this? What is something new in this equation? Anyone would like to point out? What you can infer from this equation? So you will see in the front axle, your weight is multiplied by the distance of rear axle from the CG, and there is a negative term. So this negative term signifies that when the vehicle is accelerating, your load transfer happens from the front axle to the rear axle. So you can see the reaction on the front axle has been reduced, and similarly in the rear axle you will see there is a positive term. This signifies that the load which is transferred from the front axle goes towards the rear axle. And if you will see in the case of braking, it is vice versa. The front axle weight is increased and the rear axle weight is reduced. So you can feel this, right? I mean, whenever you are sitting in the vehicle, when your driver accelerates, you feel a backward jerk. And at the same time, when the driver brakes, you will see there is a forward jerk. So this is how, I mean, simple Newton's law can be used to, visualize all the effects that you can feel in your daily life. So let's see how you can use this equation to find out the total torque required for the vehicle to, let's say, for acceleration or for the hill climb or acceleration. So let's say our vehicle is on the hill climb, and the hill climb inclination is theta. So again, we'll consider a vehicle which has a CG, weight, front axle, rear axle, uh, reactions. Now there comes a rolling resistance. Anyone knows what rolling resistance is? Anyone? Sorry? Coefficient of friction into normal rate. Okay. Okay. Not really. Anyone else? Okay. Okay. So as I said in the beginning, tire is a viscoelastic material. So like whenever the tire rotates, during the point of contact, at the beginning of the point of contact, let's say there is a radius of r. Then if you will go more beyond into the point of contact of the tire, you will find that the radius goes on reducing. So as the radius goes on reducing, there will be a differential forces acting on the each point of the circumference of the tire, and this difference of forces generates the opposite reaction in the tires, and this opposite reaction is nothing but the rolling resistance of the tire. So this is in the opposite direction. It resists the motion of the vehicle. So it is in the opposite direction of the vehicle direction. So and then comes another component which is aerodynamic force. So anyone knows what it is?
Resistive force produced by air.
Sorry?
Resistive force produced by air.
Okay, resistive force. Right. So do you think this force, aerodynamic force, is relevant for Baha?
No.
Why?
That's out of slow speed or something or
Right. So our Baha vehicle hardly goes 10, 50 or 55 kilometers per hour. Which is not that much significant if we compare it with the Formula vehicle, which goes say 250 or beyond that speed. So the aerodynamic force in those kind of speed is even more higher. But for Baha, it is not that significant. But for sake, we can consider that for now. So let's again find out our other forces which we derived earlier. So now, who are the bad guys here? The bad guy is the rolling resistance force and the aerodynamic force, which opposes our vehicle motion. Then comes the good guy. Who is good guy here in this case? Who is helping us to propel the vehicle? Right? Right. So here the traction force F rear, which is there on the rear axle. I have considered a two-wheel drive vehicle for now. So the traction force I have derived only at the rear wheel. But if your vehicle is a four-wheel drive, you can have a F front also, which will be at the front axle traction force. So how you can find out this traction force? It is basically the torque generated by the entire drivetrain system divided by the radius of the tire. So now here the torque generated is basically multiplied, the torque generated by the engine multiplied by the gear ratio of the CVT and the gearbox ratio that you have. Now, anyone can point out what is wrong with this equation? What is wrong with this equation? Is there any term which is missing? Sorry? Exactly. So here the efficiency of the drivetrain system is missing. For Baha, we generally use the gearbox system or maybe a chain drive system. So it might have an efficiency of let's say 90% or 95% or maybe less than that. So you can consider the efficiency also here. So again, just apply the Newton's law in x direction and uh, use all the parameters and apply the F rear ka formula, you will be able to derive what should be your gearbox ratio and the CVT ratio, which will be required for your vehicle to propel in certain inclination for your hill climb performance. So that's how you can basically apply all the Newton's law, find the gearbox ratios for your vehicle, which will be required for the hill climb. So similarly, if you want to find for sledge foot, you can consider a drawbar at the backside of the vehicle, which will also be one of the resistive forces which will be added here, and then you will be able to find out the gearbox ratio you require for sledge foot. So that's how you can tune your vehicle for the performance of this situation. So let's get into the lateral phase. So how is lateral force generated? Anyone? When the vehicle is in straight motion, will there be any lateral force? No, right? So whenever a driver gives the input, the steering input, a centrifugal force is applied at the CG. The centrifugal force is reacted by the tires, the four tires which are there at the four corners. Because of this, there is a slip angle which is generated. Now comes the question: what is slip angle? Anyone would like to volunteer? What is slip angle? Anyone?
The angle between velocity of the vehicle and the direction of tire is
Right, right. Same thing. Right. So exactly, it is the angle between the direction of moving of the tire as well as the direction of the vehicle velocity vector. So this is the slip angle which generates the lateral force. This lateral force is directly proportional to the slip angle. It is the same trend which we saw in the longitudinal force as well. In that case, it was only slip. Here it is a slip angle. So there the slip was generated because of the differential radius of the tire. Now here the slip is generated because there is a difference in the vehicle velocity vector and the vehicle moving direction. So this again, it is for particular, let's say 10 to 15 degrees of slip angle. It is uh, linear. Then it stabilizes after a particular slip angle. Now the slope at the linear region is nothing but your the cornering stiffness. So cornering stiffness is different for different tires. For off-road tires, we generally don't have the data available from the OEMs, but you can definitely refer to some the literature which is available. So I would request you guys to refer that as a starting point for your analysis. So now let's look at how let's visualize how the lateral force is generated. So now this vehicle is in straight line. So driver has given some vehicle steering input. So because of this, the front slip angles are generated. So because of this front slip angle, your body starts moving in your way, and then this because of this centrifugal force and body slip angle is developed. And because of this body slip angle, your tires also rear tires also there is a slip angle which is generated. So that's how the combined effect of front and rear slip angles, your vehicle is getting maneuvered in a particular direction. So now let's use the slip angles to define different vehicle responses. So what are different vehicle responses? Anyone? Characteristics. Anyone knows what is oversteer? Understeer or understeer? Yes. Right. Exactly. So the slip angles can be used to define the vehicle response in a very advanced way. But the vehicle response can also be defined by you guys if you don't know the advanced terms through the behavior of the vehicle. But we are engineers. We always look into equations to define how to visualize the things, right? So let's look at this condition. Here the slip angles in the front and the rear wheels are same. So what do you think? What will be the response of the vehicle? Anyone? No one? Sorry? Skid. Okay. So when the front slip angles and the rear slip angles are same, so the response of the vehicle is neutral state. That means whatever the input you have given to the steering wheel, it is exactly the same replicated by the vehicle, and there is no differential difference in between the input and the output. That's where the neutral steer comes into the picture. Let's look at another scenario where the front slip angles are more as compared to rear. What does it mean? What will happen? Oversteer. Are you sure? Anyone? Understood, right. So when the front slip angles are more as compared to rear, that means your rear is not skidding that much and your turning circle radius is more, and that's where the understeer response comes into the picture. Now let's look at the last scenario, which is obvious. The front is lesser than rear. That's where the oversteer of the vehicle comes into the picture. Now, what do you think? Which response should be there for our Baha vehicle for maneuverability? Let's say. Why? Better corner. Okay. Okay. Anyone else? So, what do you think the passenger vehicles are made up of? Is it oversteer vehicle or the understeer vehicle? Why? So, understeer vehicles are more stable. Uh, as a as a driver, let's say you are not an engineer, you don't know the mechanics behind it. You are someone who doesn't know the mechanics behind the vehicle. Let's say, then if the vehicle is oversteered, you will not be able to control that vehicle, and it will not be stable, right? But as a driver or as a professional driver, you will be able to control your vehicle very effectively when it is oversteer, and it helps in getting a better maneuvers in the sharp turns. So our maneuverability event has a sharp turns, very tight turns are there. So that's where if your vehicle response is oversteer and your driver is capable enough to survive in those tight turns, you will be able to get the best lap time out of it. So let's look at how the lateral load transfer happens. When a vehicle is turning right, what do you think how the load transfer takes place? Sorry? So let's imagine you are sitting in a car. Your driver has taken a right turn. What do you like? How do you feel? Do you get a jerk towards right side or the left side? Left side, right? So that means the load transfer has happened. Like load transfer has taken from the right side of the vehicle to the left side, right? So your right side is the inner wheel and the left side is the outer wheel. So the load transfer has happened in from right to the left. So let's let's consider a vehicle. We are seeing this vehicle from the rear side. So we have a right side tire and the left side tire. Again, our reaction forces are WR and WL for right and the left tire. D is the track width of our vehicle, and H is the CG height. So let's say our vehicle is taking a right turn. Uh, Newton's law, I mean, again, the inertial force will be applied in the opposite direction, and we will just apply again the Newton's law here. We will take a moment of equilibrium at point O, which is there at the right wheel contact patch. So when we apply that, we'll come to the equation, which is WL, which has a positive term again. So that means your left wheel has gained some weight, and your right wheel has lost some weight. So that the how much the weight has been transferred is basically the lateral load transfer, which is given by the term WAYH divided by 2. So this load transfer has a component of total weight, the lateral acceleration, the CG height, and the track weight. So tuning this component will help you to basically tune how much the lateral force can be transferred. But do you think CG height and the track weight can be tuned after making the vehicle? No, right? You cannot change the CG height. Up to some extent, you can change by changing the ride height of the vehicle, but that may affect some other parameters as well in the ride height. So you cannot change the CG height, and changing the track width is also practically not possible. So how will you tune your vehicle to get the better load transfer, and which will ultimately help you in making a good vehicle response? So let's look into that. So load transfer happens with three mechanisms. First is the roll resistance moment from the spring. Second is from the unsprung mass, and the third is from the direct load transfer. So when the vehicle is taking a turn, it, the springs reacts to the load transfer. It gives the rolling the resistance to the motion of the tire. You can see it in the GIF. You can see the left wheel is getting compressed, and the right wheel is right spring is getting sorry, other way around. If you are seeing from here, your left spring is getting extended, right is getting compressed. So that is something which resists the roll motion, and the load transfer is affected by springs as well as transfer mass and as well as from the rolls in the right. So this is the equation, governing equation. Don't worry, you don't have to derive this equation or something, but you can use this equation as a for tuning your vehicle. So let's see how. So I have used that equation to make this graph. So if you will see in the first graph, this axis is your front stiffness and this axis is your rear stiffness. So if you will consider rear stiffness of 12 Newton per mm and you will continuously increase the front stiffness, you will find that the load transfer in the front has increased, and other way around, if you keep the front stiffness as 12 Newton per mm, and if you will increase the rear stiffness, you will see the rear load transfer has increased. So, increase in the spring rate in the rear will help you in increase in the lateral load transfer towards rear more, and that will ultimately generate more slip angles, and hence you will be able to get the oversteer vehicle. So, in order to get a oversteer characteristics in the maneuverability event, you will have to use hard springs towards rear as compared to front. Similarly, in rear, let's consider the roll center height. You can change or tune the roll center height by keeping a variable tolling points at the rear suspension. So that will help you to change the roll center heights dynamically during different events. So let's say you are increasing the roll center height in the rear, again the same thing, and keeping the front roll center height as constant. So you'll see the lateral load transfer sensitivity in the rear has increased. Again, same thing, it will help us generate more slip angles and hence more oversteer. So that's how you can tune your vehicle for roll center height for better maneuverability. Then comes the virtual vehicle dynamic analysis. This is something which I am working on in the industry right now. So whatever the equations I have shown right now, whatever the Newton's law and all those things I have shown, you can. It's good for better understanding of the vehicle dynamics. But all those equations are already modeled by a few softwares like Adams Car, Motion Solve, or IPG Car Meter. You can use these softwares basically, and instead of going into the mathematics, you can. I mean, it is good for understanding, but you can directly give the scenarios to the vehicle and get certain parameters from it in order to get a realistic, more realistic view. So for handling, we have different load cases, constant radius cornering, the step steer, the lateral frequency response, the double lane change. All these scenarios will help you to evaluate how the handling of the vehicle is. Then comes the ride analysis. This will help us in order to evaluate the primary ride and secondary ride. Same thing again, kinematics and virtual road load data analysis. Some of you might be struggling to use that different for the different components. So what you can model a vehicle in Adam's car, run the vehicle for certain scenarios, let's say a paved road or the ramp or the sinusoidal way, whatever you want. You can replicate the same track which is there for endurance or anything. And this software package will get you the forces at certain hard points. Those forces will you can use for its FEA simulations in Access or whatever package you have. So this is how you can use the software packages which are readily available for better vehicle design, right? So it is not possible to cover all this software, how to use it right now. But if you guys want us to like cover all this parts, maybe you can request us and then you can see for the future. So that's it from my side for now. So straight roads never made the skillful drivers and engineers as well. So that's what I. So if you have any questions, you can come. You can come and meet me right now. We are short of time. There is one more lecture right now. So let's keep the Q&A offline. Got it? Thank you.
Thank you, sir, for the wonderful session. Now I request Professor Mausham sir, kindly come on the stage and give a token of appreciation. Sir, please. Thank you, sir. Students, in my left side, you can see there is a selfie point, or you can go there and take a photograph. You can do one thing, you can take the photos on that point, and you can share it with Baha SA India team through the email ID. So you will already have the email ID of SAE Baha, okay? Or you can upload these photos on the LinkedIn account and tag to the Baha team, okay? So our last speaker is Mr. Sagar. Okay, and his topic is transmission, CVT, and right line for two-wheeler, four-wheeler, and AWD. Okay, so before going to start, I would like to read his profile. He has a he has experience as a business development manager in new lead generation technology, around 1 year 3 months in Pune, and he has also the experience of research and business development associate in one bridge, around 7 months in Bangalore. So I request Sir kindly proceed for the session.
Okay, good evening. येलो कलर का शर्ट
It's fine. Now I want concentration because this is the last presentation. And just to repeat that, Anchor had mistakenly introduced me because that was a different person's profile. You have misunderstood. Okay, anyways, I'm Sagar. I'm a basically testing head at Natrax, where the selfie point is there with the Baha event is going on. So I'm handling this event since almost last 30 years. I'm involved for this entire development of the Baha event from the scratch. Though the event starting from the designing of the simulation models or setting up the rule books or conducting the event scoring. The session for my basic expertise into steering and situation, but as a new area, I thought let's go ahead with this transmission front. The different session which was conducted for 2 days may give you the technical sides of the path, of the, how the vehicle is getting developed. My presentation is a little bit longer, but as the time constraints are there, I will just cover up a few points. But apart from that, as you are in the final year, I am not interested to teach you on a single point that what the vehicle has to do. That previous expert had did it. So the main twist or main motto of this vehicle development exercise is the ability of viewers to work in a team, to understand the problem, to resolve it, and to get it evaluated, and to perform your vehicle in a better way where all experts are competing each other. Another way that I just conduct this mega workshop session almost this is my 10th year. We used to conduct in a different location. So first of all, starting with the basic questions that how many of you had studied the speaker's profile? Did anybody spend some time, spare some time on the reading that to whom I'm going to attend? कि मैं किसको सुनने वाला हूँ? And did anybody did it? Can raise their hand. Good. That was expected. So whenever you are going to attend any session, you just need to read the speaker's profile because that will give you the insight that to which you are going, to whom you are going to listen, and what could be his expertise and how, what उसमें मुझे क्या मिलने वाला है. अगर मैं ट्रांसमिशन में प्रेजेंटेशन देने वाला हूँ, तो who am I? What is my profile and what question or interaction you will get? क्योंकि एक घंटे में तो मैं आपको एक्सपर्ट नहीं कर पाऊंगा ना. जैसे किसी ने स्टेरिंग का आपको कल पढ़ाया होगा या अभी व्हीकल डेवलपमेंट व्हीकल डायनामिक्स के बारे में किसी ने पढ़ाया कि रोड ग्रेडियंट कितना होता है, तो एक घंटे में तो आप पढ़ नहीं पाओगे, एक घंटा के एक दिन में पढ़ नहीं पाओगे. लेकिन जब आप यहाँ पे आने से पहले आपका क्वेश्चनरीज रेडी करोगे ना, सो दैट में हेल्प यू, क्योंकि इस पूरे सेशन से सिर्फ 5 या 10 इंपॉर्टेंट इनपुट्स मिलने वाले हैं जो कि आपके मेन व्हीकल डिजाइन में काम आने वाले हैं, और वो इनपुट से 2 दिन में नहीं मिलेंगे. इसके लिए आपको यहाँ आने से पहले जो 10 दिन का अनाउंसमेंट है, 15 डेज का अनाउंसमेंट होता है, उसको स्टडी करें. So keep this as the first lesson that whenever you're going to attend any workshop, just read about the speakers, that their areas, so that you can be more precise. Okay, so can you have the presentation, please? Okay, so the एंड सेक्शन में थोड़ा मैं टेक्निकलिटीज, मैंने पहले ही बोला कि टेक्निकलिटीज के बारे में बात नहीं करेंगे हम. मैं इस सेशन से आपसे ये चाहूंगा कि आप की इवेंट और जो भी टेक्निकल इंसाइट्स बोले जाएंगे उसको जस्ट पिकअप कीजिए. Still not working. Oh, good. Okay, so in the driveline front, so basically driveline divides into 4 basic categories, starting from engine, your manual transmission, auxiliary gearbox, then your differentials and the wheel hub. So basically on the engine front, that the standard engine is getting delivered for the Baha, it's regional Saturn engine, its specification को check करने की permission ही नहीं होती है because it's a sponsor engine. Basically when we were designing this engine in 2009 somewhere, so one primary question came that it should be business Saturn, it should be Cummins or it should be any other company. But this engine was entirely meeting with our vehicle specification for the prime. And big status was at that point of time was kind enough to supply the engines at a free of cost at the initial point. But now, I think since last 14 years, they have changed the strategy and now it's getting charged. But yes, the engine has a specification. It's a 10 HP engine single cylinder with a 300 horses. So on the next, for the Baha business starting, that specific model has to be defined. So don't just go and pick up the engine, what Baha is asking for. Just try to ask the question why, how, and the reason behind it. Because that's the lesson learned. If somebody standing senior saying the business certificate engine that to be installed in the Baha vehicle, forget about it. Not interested at all. But why this engine? This will be your lesson learned. So, उसको ढूंढो। ये यही स्पेसिफिक इंजन जो प्राइम मूवर में यूज होता है फार्म के या लॉन के वही क्यों यूज किया है so that should be your understanding then transmission to be selected with the team of target performance means your maximum acceleration maximum torque packaging constraint when the engine is getting packed in your entire vehicle it should have a 25 clearance from all around so that fouling cannot be there your vehicle is getting toppled that traveling distance has to be there so that vehicle, your engine damages could be avoided. And based on the tractive effort required, vehicle speed and gradability, it's dependent. That's why this engine is getting chosen. That you have seen the 20-degree angle or 25-degree angle, toppling of that, or climbing and the inclined way. It requires that specified engine. This is what the engine. Now, again, transmission divided into two basically categories. It's a manual gear transmission and the CVT. I think all teams are using CVT, right?
Yes, sir.
Just be interactive session. Don't forget about the formal one. Interactive करेंगे तो दोस्तों की तरह बात कर सकते हैं. Is it okay? Okay. So all are using CVT, right? Great. So why again the CVT? It's a stepless transmission which provides you the infinite gear ratios. It's an engagement front that gives you the more reliability on your product definition, on the packaging, on the reduced losses and the shifting of the gears, which gets you smoother at that point of acceleration. So again, choosing for the transmission, basic rules that it should be, now if all are using CVT, so that's like doesn't matter. But just for your information, it must be efficient, easy to operate, highly reliable and low maintenance cost, ease of installation, low weight. So this category is defining, will serve you as an engineer what industry is expecting. कि अगर मैं आपको एक साल के बाद जब वहां से पार्टिसिपेशन हो के इंटरव्यू पैनल में बैठ के आपको क्वेश्चन पूछ रहा हूँ कि तुमने क्यों ब्रिग्स एंड सैटन का इंजन चूज किया सो ये क्यों का जवाब तभी दे पाओगे जब खुद को पूछोगे कि यही इंजन बहाने क्यों रिकमेंड किया सो अगेन द क्वेश्चन गोस कि डोंट गो ओनली विद योर अंडरस्टैंडिंग कि बाहर ने बोला है इसलिए ब्रिग्स एंड सैटन ले नहीं यू हैव टू ask yourself that why this engine is being recommended. And it is not with the engine also. Steering में अगर हम ले रहे हैं तो आपको पूछना है कि एक्टर बंद लेदर को हमने क्यों टारगेट रखा है. सस्पेंशन में जा रहे हैं तो मैक पर्सन सेट को यूज क्यों कर रहे हैं, सिंगल सस्पेंशन को यूज क्यों कर रहे हैं. Tire, it's not only the captain or the team members. Every team member is acting like a captain, nothing more than that, on his aid. So you have to be try to grasp this thing. Captain is just simply face who has two eyes, one nose, 2 ears. That's it. And representing your team. But the team member defines the effort behind that area. So अगर कोई सस्पेंशन में काम कर रहा है, कोई स्टीयरिंग में काम कर रहा है, तो आपका ये सिलेक्शन या नॉलेज अंडरस्टैंडिंग है ना, that has to be very precise कि why इसको पूछ के सीखो तो ही तुम्हारा आउटपुट मतलब हम जो इंडस्ट्री जो बाहर से एक्सपेक्ट कर रहे हैं ना स्टूडेंट से वो फुलफिल हो. Then for the transmission, it's a traction analysis. Yeah, traction analysis is dependent on the different parameters like उसका driver का weight कितना होता है. Generally we used to say एक कम weight वाला driver दो ताकि उसका ingress और exit immediately smooth out हो. लेकिन ये आपके vehicles parameters पे भी dependent करेगा. Then aerodynamic drag भी कम होना चाहिए. Transmission efficiency should be 70 to 8%. Again, when you are defining your transmission, the gradability has to be studied in a different way. अगर आप रेसिंग की एंड्योरेंस सर्किट में देखेंगे तो वहाँ पे आपको ग्रेडियंट ज़्यादा से ज़्यादा 12 to 15 डिग्री के करीब मिलेगा। लेकिन जब सस्पेंशन ट्रैक्शन में जाते हैं तो वहाँ पे आपको ग्रेडियंट अलग मिलेगा। जब आप इंक्लाइंड वे में जा रहे हैं तब आपको ग्रेडियंट अलग मिलेगा। For this event, I went to Tennessee Tech to benchmark the event or to bring this suspension and traction specially to India in the Baja premise, Natrax premise. So वहाँ पे जब हमने vehicles को evaluate किया था, so there was a gradient was tremendous, tremendous in there. They are trying to up to 30-35 degrees. So that sort of vehicle they are preparing. I think if the couple of members went for the USA event, they could have observed that what gradability or what transmission system they are going to use. Then again on the traction analysis, the power drag torque ratio is one of the important. I'll just see this slide. Now this is more important graph which we just talk about this. We'll talk about this. Now I was just talking about this now. See this typical, let's say just talking from the vehicle dynamics Thomas Gillespie. I think everybody has this book. Thomas Gillespie is like a Bible for automobile engineer. You should have that book in your library. For me, it's in my mobile, in laptop, in office, and in lab. So 4 copies are there. Whenever you're getting stuck with any problem on the technical front, you'll get answer in that book. So it's a very good book. I just recommend that you to keep this book as one of the copies. So this is the slide. This is the picture from that book itself. It's stated that in first year, when the speed is getting increased, what the traction and the resistance force to be catered. So why you on the when you are in the first gear, you used to say the gradability is more. Why this traction is getting increased or the transmission is getting easily accessible in the first gear. But the first gear reduces the speed. So when you're doing the static, when you're doing a small dynamic event, this is fine. But when you're going for an entire endurance race, this plays a very important role for the selection of the gear to maintain the speed and try to win the race. So in the first gear, it's almost 1 is to 3.5. In the second gear, it's 1 is to 6. So this torque to resistance force, this ratio to be selected properly while designing a transmission. Then after transmission, it comes with the engine, that engine packaging and the optimum center of gravity, that maintaining the engine at the specific height. So the CG of the vehicle to be measured or to be calculated in a precise way. क्योंकि CG height को calculate नहीं करोगे precise way में तो ये टॉपिंग इफेक्ट को आपको replicate करेगा. Because on the driving front, driver का एक ही aim रहता है main endurance system कि पीछे का गाड़ी आगे नहीं जाना चाहिए. So you will not bother कि अगर मुझे इस hurdle को मैं difficult way में क्रॉस आउट कर रहा हूँ तो उसका डायनामिक्स का कैलकुलेशन पूरा फेल हो जाता है जब वो 9:30 बजे फ्लैग ऑफ करके मेन रेस में चला तो उसी पैरामीटर को ध्यान में रखते हुए सीजी हाइट जो टॉपलिंग का मेजर कंट्रीब्यूटर है यू जस्ट नीड टू स्टडी ऑन दैट कि सीजी हाइट को मुझे ऑप्टिमाइज कैसे करना है जस्ट डोंट गो विद द सॉफ्टवेयर कैलकुलेशन कि मैंने कुछ वेट वगैरह डिस्ट्रीब्यूशन कर दिया उसका सीजी हाइट कैलकुलेट कर दिया नो ट्राई टू गो विद द मैनुअल कैलकुलेशन ऑफ द सीजी it plays a very precise role for the selection of the CG of your vehicle. So I'm just doing both slides not changing, just remind you. So we talked about engine. Now the next is the powertrain. So again the powertrain, it's an entire few sort of cabling tools, few type of intake and housing hoses tool which need to be connected. Sometimes pipe getting broken. So the casing or the fixing has to be in a very precise way because ultimately it does fail. A 5 days event. Sometimes people on the second days go for the different acceleration event, braking event. उसमें random panic braking में आपने देखा कि काफी सारा धूल इकट्ठा होता है. वो rusted out hoses पे हो जाता है. तो ये connections, smoothing और mounting, fixing जो है that should be on the precise way. Then again, NVH doesn't play a major role, but as a design engineer, you just need to study about the engine transmission, NVH, and different noises. So even this is an important point that auxiliary transmission used for the CVT must be mounted on the same cradle to avoid further NVH. So again, in industry, let's forget about the Baha NVH now. So NVH has to be studied precisely, which stands for noise, vibration, and harshness. So when you travel in I-20 or you travel in, let's say, Mercedes-Benz, so in that comparison, what the English plays a role? So noise is on the different front. वही टायर चलो ये R14 यूज कर रहे हैं वो R16 यूज कर रहे हैं टायर को हटा देते हैं सस्पेंशन में किस तरीके से वो इवेल्युएट कर रहे हैं harshness while the opening of the door closing of the door so ये then your performance then endurance then your durability ये इंडस्ट्री के पैरामीटर्स हैं तो इनको जितना फाइन ट्यून अपने काम के लिए करना चाहोगे ना उतना वो इंडस्ट्री में आपको यूज आएगा कि अभी बाहर में आपको मैक्सिमम इन्वेस्ट करने की जरूरत नहीं बट बाहर का व्हीकल तो हम बना नहीं रहे ना मतलब इंडस्ट्री में तो इंडस्ट्री में तो आप चलो मान लो किसी बाहर का सिलेक्शन होकर हुंडई में जा रहा है तो हुंडई में जाने के बाद जब वो टास्क स्पेसिफिक मिल रहा है वहाँ पे इंग्लिश डिपार्टमेंट में गया तो फिर उसको स्टडी स्टार्ट करना पड़ेगा तो इससे बेटर है कि इस प्लेटफॉर्म पे ही अगर उसके इन डेप्थ में चले जाओगे कि व्हाट इज एनवीएच what are the parameters contributing to the investment then it's a CVT so this is a repetitive slide so what is CVT again it's not required it's a continuous verification drive where the two pulleys are getting with the shifting of the gears to be happened then all are using CVT so again this slide doesn't matter because so basically defining that it doesn't matter because now we're talking about the difference between the manual and transmission. So again, it's a basic operations goes that engine connected with the primary pulleys and the transmitting, or you can see the forces acting on the second pictures where the transmission is getting shifted with the gear. See why this CVT plays an important role because on the ground there are lots of dust particles which may act your main hurdle while performing your main endurance. So that casing, that fixing, and the removing, all the cleaning, it to be precisely done within that 4 days. Because during the endurance race से पहले तो आप आराम से कर लोगे लेकिन during that 4 days अगर अपना अपना खुद का चेकलिस्ट बनाओ तो वहाँ पे कौन कौन से पैरामीटर्स में प्रॉब्लम आ सकती है जो कि हमें मेन रेस से पहले फोकस आउट करना है तो एक दिन मतलब उस दिन सुबह जब जल्दी आ रहे हो तो इस ट्रांसमिशन को थोड़ा सा फोकस आउट करके उस चेकलिस्ट को चेंज कर देना देन डिजाइन प्रेरित इंजन में मैक्सिमम पावर आउटपुट चाहिए अगर आप वी आर गोइंग टू डिफाइन इट मैक्सिमम पावर आउटपुट चाहिए अगेन द आरपीएम रेंज शुड बी इन द रेंज एंड द व्हीकल स्पेसिफिकेशन एक्सपेक्टेड व्हीकल वेट मतलब आप आपका ट्रांसमिशन का पैरामीटर सिलेक्शन ऐसा कंबाइन होना चाहिए कि उसकी वजह से व्हीकल का वेट ज्यादा ऐड नहीं हो देन अगेन फ्रिक्शनल रेजिस्टेंस डाटा divided with the different aggregates to the system. Then variable and fixed gear ratios, basically the variable gear ratios vary with the change in the RPM that you are basically aware and the fixed gear ratios offered by the constant motion. So the variable gear ratios with the varies from 3:1 to 9:1. Then okay, I'll just keep this slide towards the initial calculated data for the different variable slides. It's engine torque data. See on the engine front, the engine torque is getting increased at the engine range, RPM range of 2500 to 2150. So in that range, the fine tuning of the RPM setting has to be done when you are going for your acceleration, braking, or the different range. So segmental variable and the gear fix ratio again the resource availability that where the CVT is getting adjustable or available in the nearby areas what the transmission breakage if the CVT breaks or the failure of the component happens how you are going to get the accessibility and again the design constraint and packaging in that Baha buggy with your selected CVT need to be precisely choose when you are going for the main selection. So again, in your primary pulleys, there are different parameters like a flywheel, mounting saw, then guiding towers, the spiral guides. So again, इसका dimensioning part है वो luckily आपको study करने की अभी जरूरत नहीं है क्योंकि these are come in the fixed assembly part. But it plays a very important role when you are going to choose your shoe size. So उस shoe size का thickness कितना होना चाहिए, उसका uniformity कितना होना चाहिए. So that gives you the design aspects. So it's a secondary pulley again, which is connected with the primary and the belt driven. Then again the important design aspect that the primary pulley and secondary pulley to be concentrated with the minimum sleeve size, that a ramp profile which to be calculated on your Cadian drawing that there are next figures which I will be explaining on the front. That this is the path followed, the feedback flow part. This is the important one may help you to define the actual designing how to be done. They just need to first of all plot the RPM versus vehicle graph, then RPM versus gear ratio graph. Then you just need to select the riding radius. So riding radius कितना होना चाहिए. Then you see travels up. Watch what how much you are targeting for your shoe sizes. So that need to be studied, and this flow chart will drive down you to the below one diagram on the caddy in front, so that you can easily calculate the ramp profile to be driven by your CVT. So again, the final ramp profile object is an motion step essentially formed with the path and driving motion. This provides improved accuracy to the shifting mechanism. So ramp profile plays a very important role in your CVT design. So just try to follow that flow chart. That is a precise one which have been jotted down till now. So that will help you. Again, the tuning when you are going to do this, even with the mathematical modeling, the actual engine response register feedback from the ground. So ground feedback plays an important role. To point number 4, to go to the primary, most promising way the CVT turning can be conducted to the multiple vehicle runs of 50-50. So following component combination should change the flow. So you can try it out when you are doing the practices, so that on the ground when it's getting difficult, you can just try it out. That start with the first penetration spring and give the ramp profile. Second, check the different weight of the flywheel setup, or check the secondary pulling helix mounting of the spring. That will be taken care of. Then again, you just need to, after you're designing or test, and then the validation of the design to be carried out, which need to be basically RPM sensor to be checked, then acceleration measurement setup to be checked, temperature sensor. Then that will give you the primary graph of the secondary pulley RPM versus primary pulley RPM, which plays connecting two pulleys defined in one. Then again, the CVT advantages that without having disable or just go back. Okay, we'll just concentrate on this slide. Okay, initial C business, which I mentioned in the primary RPM measurement and secondary RPM graph will give the C business on which you can define your continuous CVT. Fortunately, yeah, I just come to know that on the four-wheel drive and two-wheeler drive yesterday, a detailed presentation was covered, so I'll just keep it out. But few points which I found to be mentioned on the quickly one, that four-wheel drive has a more importance rather than two-wheeler one, because your on-ground driving capability has to be defined. Both for the braking and acceleration, four wheels plays a very effective way on going. Again, output drive location and auxiliary transmission transfer the differences. Testing propeller shaft from auxiliary transmission to the front driving housing. And it gives a more advantages when you're driving on four-wheel drive vehicle with Baha these. So on this slide, it's a very basic distance to be kept it out at 300 mm on the 75 mm for the all four-wheel drive. But selecting a drive again plays a very important role on which front you want to go, so two-wheeler or the four-wheeler. But see, transmission is in general goes with the उसमें हम ज़्यादा खेल नहीं सकते वो वाला सीन है आपका इंजन फिक्स है आपके सीवीटी फिक्स है आपके पूरी डिजाइन फिक्स है तो ये ही एक ऐसा एरिया है जहाँ पे आपको टेक्निकल इनसाइट्स पढ़ने का इसका मौका मिलता है. So I request you to just go with the why question, because that will give you the more insights of the presentation. And I hope that overall session for 2 days was good and you could have learned something, because this time I have seen a very less number of people attending the workshop, because we used to get it attended by almost 700 to 800 people from the different regions. So I just want to circulate this news among your friends that the people who are coming next time, or the your colleges, it has to be mandatory, because this is a platform. We are you. Since yesterday, 2 days, I think 7 to 8 speakers attended, right? So these are the industry experts. You get a direct opportunity to interact with them on your single queries. So whenever such workshop is there, try to give a maximum attendance for the different colleges and be prepared for the questions for the speaker. Because within half an hour you cannot grasp anything, and then you will be unresolved. So it will be wasting of your time also. So just get prepared when you're going to attend such workshop. Okay. Thank you so much. I hope that it's fine. And you can write to Baha Forum, because ultimately there are a few experts where the questions are getting diverted. So on the Baha Forum, answers over your question. Thank you. Thank you so much.
Thank you, sir, for the nice session. And before giving that token of appreciation, I would like to read his profile once again. Mr. Sagar, he is assistant manager at Network Indore. He did his graduation from Shivaji University and master's degree in machine design from Walchand College of Engineering. His experience includes he worked as a PGT in Tata Motors around 1 year. Then he worked as a lecturer in Walchand College of Engineering, Cambridge. Then he has experience with National Automotive Testing and R&D infrastructure project network around 15 years. So now I request Dr. Sanjay Kumar Chalpresa, please come on the stage and give a token of appreciation to Mr. Sagar Prasad. Now we will have a group photograph. So I request all the participants kindly come forward for a group photo.
Students, the participants are all. Half of them will be standing at the stage and half of them will be standing at the downstairs. The speakers or the guests over here, please come here. Great. You can go outside on the stage. Half of the participants can go on the stage. Be fast, we don't have much time.